Ever have one of those moments where you realize, like, the universe is way stranger than you thought?
Oh, yeah.
Well, that's what this deep dive's all about. We're going to be exploring the ideas of theoretical physicist Matt Strassler.
And the thing about Strassler, he's got a real knack for taking really complex physics and making it, kind of down to earth. It feels almost like something you could reach out and touch.
Yeah.
Less about equations, more about like elegant explanations,
You're right.
which he does really well in his book on the Standard Model, by the way.
Exactly. And the conversation that we're diving into for this deep dive is one between Strassler and another physicist, Brian Keating, and they go really deep on, well, everything from Higgs boson to like why our ideas about this elegant universe we're supposed to have might be completely off.
One thing to pay attention to with Strassler is how he uses analogies.
Okay.
He's not afraid to play with them a little bit, especially when he's talking about other physicists, like, for example, Deepak Chopra.
All right, so get ready for this one. Strassler basically wants us to forget about all those like particle diagrams we struggled with in school. You know those ones with the atom that looks like a little solar system? He's saying the universe isn't like a bunch of billiard balls bouncing around. It's more like a symphony.
Yeah, and that's where this waves in an impossible C concept comes in. This is where it gets really interesting.
Okay, so break it down. What does that even mean? Like the universe as a giant instrument.
Well, think about just a calm sea for a second, nice and peaceful, like you can see into the depths. But Strassler's saying the universe is more like an ocean where we're only catching these like indirect glimpses of what's really going on.
Oh, interesting.
It's made up of all these fields and forces we can't see directly, but we see the effects. We see the ripples.
So kind of like I'm trying to think of a good analogy. Like we can't see the wind, but we can see the leaves blowing.
Exactly. And the things that we think of as particles, like electrons and quarks and all those aren't really hard little things. They're more like waves in this impossible sea.
Yeah.
And just like different musical notes, they come from different vibrations, different particles, or just different vibrations of these fundamental fields, these underlying fields that make up the universe. And just like waves in the ocean, they interact, they interfere with each other.
Okay, so instead of picturing atoms as these like little planets orbiting a sun, we should be thinking more about vibrations and frequencies and maybe even like harmonies. Is that kind of, am I getting that right? It's like the universe is one giant cosmic song.
Precisely.
Yeah.
And this impossible sea idea, this is not just some kind of new age thing. This is rooted in how physicists understand quantum fields. These are these fundamental properties of space-time, and they govern how particles interact. I know you might be thinking, wait, isn't that kind of like the ether that scientists used to believe in?
Right, right.
And you're right, there are some parallels there. But unlike the ether, which was thought to be this physical substance, quantum fields are more like the underlying, almost like the rules of the game. They're woven into the fabric of reality itself.
Okay, I think I'm starting to kind of catch the wave here a little bit. But I mean, what does this new understanding, what does it let us actually do? I mean, why does it matter?
Now, that's the really exciting part.
Yeah.
This new understanding is already starting to revolutionize technology. I mean, if we could figure out how to manipulate these fundamental waves, these quantum fields, imagine the possibilities.
Yeah.
Energy production, communication. It could be unlike anything we've ever seen before.
Wow. So it's like we're on the verge of like a whole new area of scientific understanding.
Exactly. And it all starts with wrapping our heads around this idea of the universe as a symphony of waves rather than just a collection of discrete objects.
Okay, so we've got this picture of the universe as this giant wave-filled ocean. But where does the Higgs boson fit into all of this? Because it's like this rock star particle, right? Everyone's always talking about it.
Oh, yeah. You can't talk about particle physics without talking about the Higgs. But Strassler points out that we get it wrong a lot of the time.
Yeah, it's usually like simplified down to that whole God particle thing, right? The one that just like magically gives everything mass.
Exactly. And while it's true that the Higgs field IS connected to mass, it's not as simple as the Higgs boson, like running around and giving mass to every other particle.
Yeah.
You know what I mean?
Right. So what is the Higgs field then? I mean, how does it actually work?
Okay, so think about it this way. Imagine the universe is like a giant swimming pool. I know we just did the ocean thing, but stick with me.
Okay.
The water in the pool, that's the Higgs field.
Right.
And some particles,
Yeah.
like photons, light particles, they just zip right across, no problem. They're like those Olympic swimmers who just, like, perfect form, no resistance. And no resistance means no mass.
I'm with you so far.
Okay, but other particles, like the ones that make up you and me, were like, you ever try to wade through a pool and you forgot your floaties?
Yeah.
So you're interacting with that Higgs field, that water, and it creates resistance. And that resistance is what we observe as mass.
Hold on. So the Higgs boson itself, is that like, what is that in this analogy? Like a beach ball.
I like that. Um, it's more like if you jumped into the pool, a cannonball, it's a ripple in the Higgs field itself. It's a disturbance, right? That we could actually measure.
Okay, that makes a lot of sense. I'm never going to look at a swimming pool the same way again. But here's where things get even a little bit more wild, at least for me. So Strassler's also kind of backing away from this idea that the universe has to be elegant, and symmetrical, the way physicists have always kind of thought it must be. He's not so sure anymore.
Yeah, he's definitely challenging that assumption that a lot of physicists have, this deeply ingrained idea that the laws of physics have to be beautiful. They have to be simple. What if the universe doesn't care about our human ideas of elegance?
Right.
What if it's just, I don't know, messy and complex?
Like that junk drawer everyone has. You know there's good stuff in there, but good luck finding it.
Exactly. And this is kind of where his whole point about analogies being tricky comes back in.
Yeah.
Just because we can come up with a nice, neat explanation, a nice story, doesn't mean that it captures the full messy, chaotic reality of how the universe actually works.
So sometimes our desire for a simple explanation, it can actually get in the way of like a real understanding.
Exactly. And we see this all the time. I mean, think about, how we explain how airplanes fly.
Airplanes, right. That's like the perfect example of, we want the simple explanation, but it might not be the whole story. I remember learning about lift, like Bernoulli's principle, right? Faster air on top of the wing, lower pressure, it's sucked upwards. It always kind of felt a little hand-wavy to me, but I never really questioned it.
Yeah, and it turns out there's a lot more to it than that. I mean, Bernoulli's principle, it's there, it plays a role, but it's not the whole story. Like, a lot of the lift is actually generated by the angle of the wing and how it deflects the air downwards. Plus, there's all this complex fluid dynamic stuff going on that they don't even get into in, high school physics.
So it's not that the simple explanation is wrong, it's incomplete. Kind of like those particle diagrams, right?
Just full to a point.
Helpful analogy, but
misleading.
Yeah. And it's like you were saying, about Strassler and the elegance of the universe, or maybe the lack of it. What if it's just inherently messy and complex?
Full of these emergent properties and unexpected connections. Like, what if our human brains, as amazing as they are, they're just not equipped to really grasp, the true nature of reality in all its, messy glory.
So where does that leave us? I mean, if we can't rely on these simple explanations or these elegant models, how do we even begin to make sense of the universe?
Well, that's the million-dollar question, right?
Yeah.
But I actually think, that's where Strassler's real message is one of hope,
Okay.
He's not saying that we should just, give up and throw our hands up. He's saying we need to be willing to kind of embrace the complexity, embrace the mystery of it all.
So it's less about, finding all the answers, and it's more about learning to ask the right questions.
Precisely. Yeah, and that's something that anybody can do, right? You don't have to be a physicist to do that. It's about cultivating a sense of wonder, and curiosity about the universe.
It's like Strassler is opening a door to this vast, mysterious landscape and being like, come on in, it's a weird, wonderful place. You don't have to be a physicist to appreciate it.
Right. And who knows what we might discover along the way, right? I mean, maybe by embracing the messiness of it all, we stumble onto something truly profound, something that changes how we think about ourselves and our place in the universe.
So for someone who's listening to all this, what would you say is the one thing to kind of shift their perspective, the thing that really blew your mind?
Oh, man. That's a tough one. There's so much.
Yeah.
But if I had to pick one, I think it would be this. What if the universe really is like a giant musical instrument,
Yeah. What if particles are just vibrations and fields are, the very fabric of space-time? I mean, it makes you think about reality in a whole new light. What is energy? What is vibration? And how do those things maybe even connect to consciousness? We were talking about Deepak Chopra earlier. These are the kinds of questions that Strassler's work really opens up, and, they push at the boundaries of what we think we know about ourselves and the universe. And those are questions worth thinking about.